Well, good morning.
Good morning.
Dave Lafferty. I'm a consultant and also an ARC associate. And but I want to sort of draw upon my almost 40 years in the business as working for people like BP and really sort of present the owner-operator aspect of this transition from the projects world to the operations world. So the basic premise is that in the design and construct world, we've seen enormous strides in productivity and the quality of product. Everything from scanning the initial site to understand what the existing conditions are, to using scanning at the end to understand how it was finally built. But really where the huge strides have been in the CAD world, where there's just been enormous increases in productivity and then the quality of the product that comes out. However, we haven't enjoyed that same kind of strides in the operations world. So what I want to explore this morning is how can we bridge some of the successes that we've seen in the capital world into the operations world. So what are some of the basic challenges that the operations world is up against? And as previously mentioned, the poor handovers is one of the key pain points. Part of it is because as an owner-operator, we've asked our EPCs to focus on bringing projects in on time and on cost, on budget, and didn't really ask them to look into the aspects of sort of build to run kind of aspects of it. And also, we tended to not get our operations people involved until the commissioning aspect of it. And then at that point, they point out very obvious things like, if you just moved this valve over a little bit, I could actually get access to it from the catwalk rather than having to build scaffolding to get to it. Just simple things like that, that in the design phase would have been easy to take these great CAD tools and move it. But once it's welded up, it's a little hard to move, right? So the other main pain point that we're up against is sort of this, in the operations world, we have a lot of incomplete, inaccurate, and missing data. Part of it is, so there's a couple, three reasons around that. One is, you can't just take a 3D CAD model and in bulk hand it over to the operator for a number of reasons, but one of which is inside of that CAD model is quite a bit of intellectual property. That's their magic sauce of how they outcompete the other EPCs. So there's macros that do estimating and all sorts of other things. So it isn't just as easy as saying, well, here's the model. So there's aspects there. More fundamentally, though, the project data reflects the as-designed state, not necessarily the as-built state. And then another reason is in operations, your data starts to decay pretty rapidly because your plant changes over time. You have maintenance activities, you have small projects, you have turnarounds, you have lots of things why your plant then changes. The third real challenge is it's very difficult to access and to visualize that operations data. Some of the reasons behind that is the tools are really geared for design, not visualization of operations data. So these design tools are excellent tools, but you have to go to 2 years of college to learn how to run them because they are so full-featured and robust. Not necessarily geared for the operations guide. Ask a simple question like, show me all the relief valves that have not been inspected in the last 2 years. Then the other thing is that the operations data that tends to be highly siloed into these systems. So you'll have your master equipment list in one system, you'll have your inspections in another, you'll have your maintenance records in yet a third, and it's really difficult to get a complete picture of your asset situation. What that means to the operations world is you have a lot longer time to first oil. First oil is the time where you can safely produce oil. And what that means is that the rate of return for these capital projects have not been all that great because it's taken a lot longer. Not only do you have a lot of capital tied up in these projects, but more importantly, you're not generating revenue until first oil. So very important. The other thing you see is a lot of high operations costs, things because of this inefficiencies of these highly siloed systems. So you have people doing a lot of low value work of logging into this system to get that piece, and then another system to get that piece, and things like that. A more fundamental consequence, though, is that we're exposing our workforce to a lot more risk than we need to. Because we don't trust the data, because we don't have access to the data, what we tend to do then is walk the line. We go down to the physical asset, and then we will then do a pre-project assessment before I do maintenance work or a project. That means that I now have people that have to fly to offshore rigs, that I have people working at heights taking with a physical tape measure and measuring stuff rather than doing it virtually. And then the other aspect of it is the high cost of compliance reporting. So whether it's with OSHA or the Air Quality Board or something like that, something as simple as how many relief valves do you have in your refinery that release to the air? And the good part is that you'll have 3 or 4 answers because you'll have different groups tracking them on different spreadsheets. The bad news is they're all different. So you get into lots of issues with the regulators, plus you spend a lot of time rationalizing these silos and trying to get the right answer. So, lots of ways that you can approach sort of bridging the success of the capital projects into operations, but one particularly interesting approach is to use a virtual facilities. And what you would do is to take the project data that is so rich and robust in the design and construct world and translate it into a virtual facility. So what is a virtual facility? What it is, it's a high fidelity, realistic digital representation of your plant. It's 3D in nature. It has the inventory of your assets, so things like your rotating equipment, but also your elbows, your piping, your flanges, all these other aspects of your asset management. But one of the important things about a virtual facility is that it has objects. It isn't just a pretty picture. Because objects are important, because in the CAD world we learned that those are very important because it isn't just enough to understand that you have a pump there. What you also want to understand is what is upstream and downstream of that pump. What are the relationships of that? What do I belong to? Do I belong to line 1 or line 2? What is the process flow? All those kinds of relationships that you can't do if what you have is just a bunch of pixels. So it's very important that you're able to maintain those kind of relationships between your assets in a broader process aspect. And the other thing is that a lot of this can be created from the 3D CAD that was done in the project thing, or in a case of a brownfield, you can do laser scanning. So there are ways that you can then go there. So that's my definition of what I mean by virtual facility. The benefits are number one, you get reduced labor costs because you have easy-to-use tools. You now have people doing high-value work rather than low-value work because now this this virtual facility becomes a portal into all these various views of your assets. You're able to do a lot of work virtually rather than in place. That leads into the second benefit, is that you really reduce the amount of exposure that these workers have, because now you can do a lot of work virtually where you can have design teams or operations teams onshore. You can have them doing the work without having to go out to the field and measure that. So places like Canada, Alaska, offshore are just absolutely, a lot of risk is reduced just simply transporting these people to these kind of sites. And then the last thing is you see improved data integrity, and the reasons why is that the data is linked, it's not copied. So one of the worst things you can do is make the problem worse by copying all the data into yet another version of the truth, right? So, and sort of the relief valve story, right? You know, you don't know which version is true. The other thing is that you want to make sure that the underlying data structures support operations data. You know, if you try to take a tool like a CAD tool that's a beautiful set of software, but what it's designed to optimize is to create objects and make those objects into a design. That might not be the best underlying structure for accessing and visualizing your operations data. Another key aspect of the data integrity is suddenly things like your ISO drawings become reports out of that model. You no longer have to draft all this stuff up, put them in the drawer, and they're out of date before the ink dries. Now you can go in and fit for purpose, you can create an ISO for at the angle or the view angle that is right for the task that is at hand, and so it really helps with the fact that you get around the fact that your paper documentation tends to always be stale. And then the last thing is, by incorporating tools and process, you make sure that model, that virtual facility, reflects the as-is conditions. So you want to evergreen that model, making sure that your management of change is in place such that those changes get reflected back. So what are some of the things that you can do with a virtual facility? Well, one is inspections. Now that you have a robust view of your operating environment, you can plan your inspections. What that means is that I decide where I inspect, how I inspect. Do I use a ultrasonic measurement device? Do I use an X-ray device? Those kinds of things. And how often? Do I do it once a year? Do I do it 3 times a year? Do I do it once every 5 years? That kind of thing. So you can help with that. The second thing is the actual execution of those inspections. You might have as many as 150,000 points that you need to inspect. They might be organized per your process flow, or what they call corrosion loops, when in fact, if you're going to build a scaffolding to get to a pipe rack, you want to inspect everything that's up there regardless of what flow it's in. So you can optimize the execution of inspections. And then the third thing you can do is now you can visualize the results of those inspections by saying something like, show me, color code the pipe based on wall thickness, 100% to 50% loss kind of things. Show me the corrosion rates, and such that I can understand in a spatial context where these high corrosion rates are, because a corrosion rate at a low spot in the pipe might be normal. A corrosion rate at a high spot in the pipe might not be normal. So the same corrosion rate has to be, it will mean different things based on the spatial context that it's in. Maintenance, a lot of that, we talked about the ability of being able to virtually walk down that job and get all the details and put together. Now you can put together virtually that work package without there, so you get better information, you can trust that information, and now you can accelerate that. You can also look at a bunch of work orders in a spatial context, and there might be an opportunity to combine work maintenance activities. If you're already going to be in that area, there might be stuff not due for another month, but it would make sense to do it. And also the simultaneous operations. There are certain operations that you might be able to do at the same time in the same place. There might be other operations that you can't, because even though you're separated by a deck or two, you might be welding at the same time somebody else is, releasing gas or something like that. So a way to really optimize your maintenance activities. Turnarounds are very similar to maintenance, but just an order of magnitude bigger. Environmentally, lots of places with it you have to inspect to make sure that you're not leaking product to the air, things like that. And then training, where now you have an environment that reflects you as is condition. You can train operators and maintenance people. Well, in theory that sounds great, right? But does it really happen in practice? So what I brought was a use case out of Saudi Arabia. It's a very large petrochemical plant, started in October of 2011. And what they did was they took the project data and they put it into 3 basic databases. They used the NFX Reality Link to build the virtual facility. And then they use their inspection database, Meridian in this case, to basically put together their integrity management plan of where do they want to inspect the various piping. And then they use SAP for basically their master equipment list and their asset catalog and those kinds of things. So when they started out, they felt that they made a pass at the integrity management plan, and they came up with 150,000 what they call thickness measurement locations, or TMLs. So they had 150,000 discrete measurements that they felt they had to take in order to ensure the integrity of this plant. What we realized is by building this virtual facility, there was a number of sources of value. Number one, we were able to reduce the number of inspection points. And the reason why is that these inspection points are created by taking a number of different internal and external guidelines, and sometimes they overlap in intent. And so unless you can look at these, and so the result is you over-inspect, because the API guidelines calls for maybe 12 inspections for this piece of pipe. Your internal guidelines calls for 14 inspections, and when in fact maybe only 10 would cover the intent. So by being able to visualize these inspection points in a spatial context and understand the underlying attributes of those assets, the wall thickness, the steel type, those kinds of things, you can better plan that. The other source of value was the optimization of the physical inspection process. So now I'm able to reduce the number of crews because, number one, I'm inspecting a lot less, but number two, of the crews I do send out, I can optimize when I put up scaffolding or other sorts of things like that. I can optimize their activities, because now I can I can do this in a spatial context. And then the last thing was it eliminated a lot of the low-value work that we mentioned, key punching stuff in and things like that. So if you look at the actual numbers, what they came up with was around $12 million to inspect these 150,000. So if you reduce the amount of inspection points, now you get around a $5 million, almost $6 million savings just by reducing the amount of inspection locations. You're just doing less work. But you also optimize your execution, so you're reducing the cost of the inspection crews, the scaffolding, the supervisors, all that. So you now are generating yet more savings, again around $4.5 million. Bottom line is that even though the initial investment was a little over $2 million, the payback was in less than 4 months. Pretty impressive. And these are tangible savings. These aren't, there's other intangible savings of improved safety and reduced risk. These are crews that you don't have to hire. These are immediate saving kinds of things. They have a bunch of next steps. They'd like to, the nice thing about a virtual facility is now you can set lots of verticals on top of it. So you can look at isolation procedures and maintenance notifications. We mentioned the optimization of maintenance, the synops, things like that, turnarounds, HAZOP analysis, where you can actually walk through a job virtually to identify all the hazards. And if you think about it, a HAZOP analysis where you say, I have this really dangerous place, and the first thing I'm going to do is walk through it to find out all the dangerous stuff. This is sort of cool that you can sort of look through there and say, no, there's all these hazards that I need to deal with during this job to make sure that we can work safely. And then there's a lot of training opportunities. So, in summary, lots of benefits can be realized by transitioning from the CAPEX to the OPEX world using the virtual facilities. However, and there's always a however, you really need to make sure that you do 4 things to recognize those benefits. Number 1, you need to translate that data, make sure that you get it properly bridged, translated from the projects world to the operations world. You need to make sure that your tools can easily visualize that operational stuff spatially, because there's a very big spatial context to operations data. The third thing is you need to really make sure that you have process people and software to ensure that the data reflects current plant conditions. And then the last thing is you want to really make sure that you utilize these 3D tools through the entire plant lifecycle, all the way up to and including decommissioning, to really get that value.